All right, let's get this show on the road. Today, we're taking a deep dive into the world of software testing techniques.
The unsung heroes, you could say,
Yeah,
right?
exactly. All those apps and websites we use every single day.
They don't just magically work.
Yeah, there's a whole hidden universe making sure that software actually, well, works.
Absolutely. And today we're going to break it all down.
We're using a guide to different testing techniques.
It's perfect for anyone who's ever been curious about this stuff.
Yeah, whether you're a total beginner or just need a refresher, we've got you covered.
We're going to unpack some seriously clever techniques.
Way beyond just clicking around and seeing if things break.
Exactly.
So first things first,
The why.
yeah, the why. Why not just test everything?
I mean, you'd think that would be the solution, wouldn't you?
Yeah, it sounds pretty logical to me.
Right. But imagine trying to test every single possible input
Oh, boy.
for even a simple number field, like one that takes values from 1 to 10.
Oh, that would be a nightmare.
You'd be testing forever. It's just not realistic, is it?
No, definitely not. So it's more about being smart with your time
Exactly. Efficiency is key.
rather than just brute forcing it.
Right. And that's where these techniques come in.
Okay, like what?
Well, take boundary value analysis, for example, or BVA for short.
BVA.
Okay. All about focusing on the edges of things.
The edges? Like that 1 to 10 example from our source material.
That's a perfect illustration.
So instead of every number between 1 and 10, we'd focus on 0, 1, 10, and 11.
You got it.
But why those specific numbers? What makes them so special?
It's kind of like if you were testing the strengths of a bridge, right?
Yeah, I can see where you're going with this.
You'd want to focus on the stress points.
The weakest links?
Exactly. The areas that are most likely to fail under pressure. And with software.
We're doing the same thing.
Exactly. We're looking for those software stress points, those edges where things tend to break down.
Interesting. So BVA is like finding those weak spots
And them hard.
Yeah. But how do we make sure we're testing everything else?
Great question. That's where equivalence class partitioning comes in.
Okay, now that's a mouthful.
I know, right? But it's not as complicated as it sounds.
Awfully.
It is, actually. Think of it like doing laundry.
Laundry. Okay, this should be good.
You wouldn't wash each sock individually, would you?
No, I'd go insane.
Exactly. You group similar items together.
Right. Makes sense.
And equivalence class partitioning is basically doing that with software inputs.
Okay, I think I see where you're going with this.
So, like in our source material, if an input field takes numbers from 1 to 10,
Right.
and then again from 20 to 30, those are two separate classes of input.
Like sorting your whites and colors.
Exactly. And you'd also have classes for invalid input, anything below 1 or between 11 and 19.
I see. So you test a value from each class.
And that gives you comprehensive coverage without testing every single possibility.
So BVA is your laser focus.
And equivalence class partitioning casts a wider net.
They work together. A dynamic duo of bug busting.
Love it. Now let's move from input values to the logic behind software decisions.
Ooh, getting a bit more complex.
That's where decision table testing comes in handy.
Decision table testing. Okay.
Our source material had a great example, a submit button.
The one that only works after you fill out certain fields.
Yes, we've all run into those, haven't we?
Countless times.
Decision table testing helps us map out all those conditions and their possible combinations.
Creating a kind of visual guide.
Exactly. A visual representation of how decisions are made in the software.
So like a flowchart, showing every possible path and outcome.
You got it. And this is especially helpful for really complex systems.
I bet, so you don't miss any steps.
Precisely. You can spot any missing logic or conflicts.
It's like making sure all the gears are meshing in a machine.
A great way to think about it.
Yeah.
And no more, why isn't this button working moments, right?
No more frustration.
Exactly. Now, speaking of frustrating moments, have you ever been locked out of an account after too many wrong password attempts?
Oh, who hasn't?
It's a classic example of state transition testing.
State transition testing. Interesting.
This technique focuses on how a system changes its state based on different inputs.
So the system goes from unlocked to locked based on what you enter.
Precisely. State transition testing lets us systematically test all those transitions.
So we can be sure the system responds correctly every step of the way.
Exactly. It's like mapping out every possible path a user could take through the system.
And making sure there are no dead ends or unexpected surprises.
Couldn't have said it better myself.
This is great.
Now, for our last technique, let's add a dash of art to our science, shall we?
Ooh, I like the sound of that. What's on the menu?
We're talking about error guessing.
Error guessing. Sounds a little more intuitive, a little less formal.
You could say that. It definitely leans on a tester's experience.
And their ability to put themselves in the user's shoes.
Yes. And in the shoes of someone who understands how things can go wrong.
Like, oh, I don't know, accidentally deleting a whole paragraph because you hit the wrong key.
Exactly. Or crashing an app by doing something completely
We've
unexpected.
all been there.
Error guessing draws on those past experiences, known issues, even gut feelings.
So it's not just random guessing, it's educated guessing.
Exactly. Seasoned testers use their knowledge to predict and prevent those "how did that even happen?" moments.
So it's like being a detective looking for clues.
Absolutely.
That's cool. And we've already covered 5 techniques: BVA, equivalence class partitioning, decision table testing, state transition testing, and error guessing.
All playing a crucial role in making the software we use every day as reliable as possible.
It's a lot to take in, but it's fascinating. But software isn't static, is it? It's always evolving.
That's right. And that leads us to the next part of our deep dive.
Where we'll explore how software testing is adapting to the ever-changing landscape of technology.
See you there.
So we've got all these testing techniques, right? BVA, equivalence class partitioning, decision tables, state transitions, even error guessing.
It's a pretty good toolkit, yeah?
It is. But software, it's not static, is it?
No, it's constantly changing.
It's always evolving, so how does testing keep up with that?
That's a great question. And honestly, that's what makes this field so exciting.
Okay, so it's not just about learning these techniques, it's about,
Adapting.
yeah, adapting, staying ahead of the curve. What are some of the big things driving this evolution in testing?
Well, one of the most impactful shifts has been the rise of Agile and DevOps methodologies.
I've heard those terms thrown around, but
They really emphasize rapid development cycles.
so everything's moving much faster.
Exactly. And continuous integration, which means testing has to be faster too.
And more automated, I imagine.
Exactly. You can't be doing everything manually anymore.
Right. It's not like the old days where you just throw the finished product over to the testers at the end.
No, not at all. Testing is integrated right from the start.
So it's a much more collaborative approach.
Very much so.
Mm.
And it's led to new techniques like test-driven development.
Test-driven development, okay.
This is where tests are written before the code itself.
Wait, hold on. The tests come first.
I know, it sounds a little crazy.
It does. Like you're writing a recipe based on what you want to taste, not the ingredients you have.
That's a great analogy,
Yeah.
but it's incredibly powerful.
How so?
Well, it forces developers to think about functionality from the get-go.
Before they even start writing code.
Exactly. And about potential issues.
So it's got a roadmap for development almost.
You could say that. It guides the process rather than just validating it at the end.
That's a big shift. And then you have mobile apps and cloud-based services. That must make things even more complicated for testing.
Oh, absolutely. Mobile devices, they bring a whole new set of challenges.
Like what?
Different screen sizes,
Yeah.
network conditions, operating systems.
Oh, yeah. I can see how that would be a nightmare.
It can be, but it's also what keeps things interesting.
Right. And cloud-based services, they're constantly being updated, right?
Yes, constantly evolving. It's like trying to hit a moving target.
How do you even test something that's always changing?
That's where specialized approaches come in.
Like what?
Mobile testing, cloud testing, performance testing.
So it's a constant back and forth.
Between developers building new features and testers trying to break them.
But isn't it all ultimately about the human factor?
It is. We can talk about techniques and tools all day long.
But testing comes down to people, right?
Absolutely.
Right.
Those tools are just that, tools. It's the tester's skill and experience that really make the difference.
Right, like that error guessing we talked about.
You can't automate intuition.
Exactly. Experienced testers, they develop a feel for where bugs might be lurking.
They understand how users think, how systems can break.
They use that knowledge to design tests that go beyond the obvious.
It's like being a detective, really.
Yeah, always on the lookout for clues.
And always learning, adapting their methods.
Speaking of adapting, we can't ignore the elephant in the room, AI and machine learning.
Right. They're changing everything.
So how are they impacting software testing?
In a big way. One of the most promising areas is test automation. AI algorithms can analyze huge amounts of code and user behavior.
To look for patterns.
Yes. And potential problems.
So it's like having an AI assistant that helps testers focus their efforts.
Exactly. It's incredibly efficient. And AI can also be used to analyze testing data.
To spot trends and potential issues that humans might miss.
It's all about augmenting human capabilities, not replacing them.
So the future of software testing is this blend of human expertise and AI power.
Precisely. It's a fascinating time to be in this field, that's for sure.
It sounds like it. So for our listeners who are thinking, this is cool, but I'm not a software developer or tester, how does this apply to me?
Well, here's the thing. We're all users of software.
Every single day.
Apps, websites, devices, they all rely on these testing processes to function.
So even a basic understanding of software testing gives you a new perspective.
It's like peeking behind the curtain.
Seeing all the effort that goes into making our digital experiences smooth.
Exactly. But what about when things don't go smoothly? Those frustrating bugs we all encounter.
That's where you come in. Now that you understand the basics of testing,
You can be a more informed user.
and give better feedback to developers.
Exactly. The more specific your feedback, the easier it is for them to fix the issue.
It's like being a citizen scientist, helping to make the digital world a better place.
I love that analogy. And it highlights the impact of software.
It goes beyond just those everyday frustrations.
Think about the software that controls our cars, our medical devices.
Right, the stakes are much higher in those cases.
Absolutely. It's not just about a game crashing, it's about safety and security.
Even people's lives.
Exactly. So software testing, it becomes about responsibility, attention to detail.
It's understanding the potential impact of your work.
You've got it. And that role is only becoming more important as software gets more complex.
And more integrated into our lives.
Absolutely. So we've covered a lot of ground in this deep dive.
From the basic techniques to the evolution of the field, and even some ethical considerations.
What would you say is the one big takeaway for our listeners?
I'd say, remember that software testing isn't some mysterious thing.
It's a process, a set of techniques.
And a mindset, most importantly.
It's about being curious, being skeptical,
Always looking for ways to improve the quality of the software we all rely on.
and even the smallest bug can have a big impact down the line.
Attention to detail is everything.
Absolutely. It's about being proactive, thinking like both a user and a developer.
So the next time you hit a glitch, take a moment to appreciate the unseen world of testing that's working behind the scenes.
And maybe, just maybe, you'll be inspired to explore this field yourself.
It's full of challenges and rewards, right?
It is. There's always a need for talented people who can combine technical skills with a passion for quality.
Well said. Let's talk about those bugs,
The ones that make you want to scream.
Exactly. Now that we know a bit about testing, do bugs seem different?
I mean, they should, right?
In what way?
Well, think of every bug as a clue.
A clue.
Yeah, it's a sign that maybe something was missed during testing.
Ah, I see.
Or maybe users are interacting with the software in a way that wasn't anticipated.
So instead of just getting annoyed...
We can actually use this knowledge to give better feedback.
Oh, that's interesting. So how do we do that?
Be specific. Tell the developers exactly what happened.
Like what steps you took.
Exactly.
Yeah.
And what you expected to happen.
That makes sense. The more info they have, the easier it is to fix.
Right. It's like being a citizen scientist.
Oh, I like that. Contributing to a better digital world.
Yeah. And it brings up a really important point. The impact of software goes way beyond those everyday frustrations.
What do you mean?
Well, think about the software that controls our cars.
Oh, right.
Or medical devices, financial systems.
Yeah, the stakes are much higher there.
Exactly. It's
Yeah.
not just a game crashing or website being slow.
It's about safety, security, people's lives even.
That's where software testing becomes about so much more than just technical skills.
It's a huge responsibility.
It is. It's about attention to detail, understanding the potential impact of your work,
So testers are kind of like guardians, in a way.
protecting us from, code gone wrong.
I like that. And that role is becoming even more important as software gets more complex.
Absolutely. More integrated into every aspect of our lives.
So we've covered a lot in this deep dive.
Yeah, we have.
From those fundamental testing techniques to the evolution of the field and even some ethical considerations.
What's the one big takeaway you'd want our listeners to walk away with?
I'd say remember that software testing isn't this mystical, unknowable thing.
It's a process, a set of
Yeah.
techniques.
And a mindset, really.
It's about being curious, skeptical,
Yeah, always looking for ways to improve the software we all rely on.
and never underestimate the impact of even a small bug.
Right, attention to detail is everything.
Being proactive, thinking like both a user and a developer.
So to everyone listening, the next time you encounter a glitch,
Take a moment to appreciate the work that goes on behind the scenes.
yeah, the unseen world of software testing.
And maybe you'll even be inspired to explore this field yourself,
It's a fascinating field.
full of challenges and rewards.
Well, that's all the time we have for today.
It's been a pleasure diving into this topic with you.
As always. And to our listeners, thanks for joining us on this deep dive into the world of software testing.
Keep exploring, keep learning.
And until next time.
Happy testing.